Hello guys, this week I will gonna make a summary about last things. At first, we start with the MOSFET. MOSFET is the metal oxide semiconductor, acts like the capacitor. That the MOSFET's the important point is that when the inversion occurs, we should know the point that threshold. We should know the inversion point of the MOSFET. We call that the threshold voltage, and we can calculate the threshold voltage with the flat band voltage and the silicon dioxide, the capacitance, and the voltage on the body substrate. And the next, next is the MOSFET, which it is quite important that the distinguish the which is the N-FET or P-FET with the channel of the body. And the MOSFET, the important point is that the drain voltage and source voltage, we can control those two things, and we can make the depletion mode, which that even if that the gate bias can't overcome the threshold voltage, but if the drain bias is quite high, that can make the enough gap between the drain and source, then if the gate bias is lower than threshold voltage, but the current can flow from the source to the drain. So it is quite important, and we should know that the IVG curve and the IDVDS curve. So that is end of the MOSFET. And in appendix, there is a subthreshold voltage that it is dealing with the interval between the before the threshold voltage, and we call those things that subthreshold voltage. If we see that in normal graph, then the voltage is quite small, so we can distinguish that. So we use the log scale to research the subthreshold voltage. And the important point of the subthreshold voltage is that if we can calculate the N, so that N means the coupling between the source, body, and gates. That if N is similar to 1, then it means that the MOSFET acts like X most idle, because there is a Boltzmann limit that the subthreshold value S can't lower than the 16 millivolts. That is, thank you.